In this video, we talk about mixtures and solutions. So mixtures or solutions are just part of mixtures. That is something that we are going to uh, look at in the video. Now, uh, what is a mixture? Really, when you combine two or more elements or compounds or molecules in any proportion, usually without any chemical bonding connecting the different substances you are combining, you have a mixture. For example, the M&Ms, we have M&Ms of different colors combining in one packet. So the M&Ms are mixtures in that case. So when we look at mixtures, we have two major types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixtures, we have also two types of them. We have homogeneous mixtures that we call solutions and homogeneous mixtures that we call colloids. In terms of heterogeneous mixtures, we have suspension. And we will look further into these mixtures. Now, what is a heterogeneous mixture? Usually, a heterogeneous mixture, we have two or three substances in one container, but these are not uniformly distributed, which means we can easily distinguish. So we can easily distinguish different components of the mixture. So we can easily do that when you are dealing with heterogeneous mixtures. Now, in this type of mixture, components usually are in different phases. We say components are in different phases, which means they are distinguishable. So one example is M&M. There we have candy of different colors. So we can easily distinguish different colored candy from the M&M packet. Another example, another example of a heterogeneous mixture. We can have a container with different types of rocks. So that is, so it's easy to distinguish these different types of rocks. And also a container of soup. Let's say chicken soup. So in that case, we have water, we have chicken, and other things. So we can easily distinguish this type of mixture. We can see water in there, we can see chicken in there, we can see other condiments added in there. So that type of mixture is known as heterogeneous mixture. Then we have homogeneous mixture. So this type of mixture, the composition of components in this mixture is uniform, which means you cannot easily distinguish the components of the mixture. So an example is if you dissolve salt in water. So if you dissolve salt in water, what happens? The salt will, let me just erase this part. So if you mix salt in water, the salt will disappear, which means you cannot distinguish different components of this solution. You cannot look at the liquid and say this part of the liquid is salt, this part of the liquid is water. It just looks like water because everything is uniformly distributed in there. Another solution is air. So air has nitrogen, oxygen, and other gases. But you cannot distinguish each type of gas in there. They just look like gases. Actually, we don't even see the gases. So that type of mixture is homogeneous mixture because everything is in a single phase. It is not distinguishable. Now, if we look at these types of mixtures, we can further group the homogeneous and heterogeneous mixtures. We can put them into 3 groups. So as we said, homogeneous and heterogeneous homogeneous mixtures, we have 2 groups of them. That is colloids and solutions. Heterogeneous mixture, we have a suspension. So this is heterogeneous mixture. Now, here we have a comparison of the properties of solution, colloid, and suspension. So the question is, why should I call a mixture a solution? Or why should I call it a colloid? Or why should I call it a suspension? So first, we look at the particle size. Now, if the particle size in the mixture is less than 1 nanometers, that mixture is going to be called a solution. Now, if you have particle size of the components of the mixture within 1 to 100 nanometers, that mixture is called a colloid. Now, if the particle size of the mixtures are more than 100 nanometers, that mixture is called a suspension. You can also use the appearance. A solution will be a clear mixture, so it will be clear, while a colloid will be cloudy, so it will be kind of like milky or something like that. A suspension will also be cloudy. In terms of being able to separate, if you have a colloid, you cannot easily separate. If you have a solution, that is, you cannot easily separate the components of the solution. The same thing with a colloid. A colloid is not easily separated. But if you have a suspension, if you leave it for a while, the solid part is going to settle at the bottom of the liquid. So it will look like this. In the end, we have liquid here and we have solids settling down here. That would be a suspension. While a colloid and a solution, you are not going to see solids settling down at the bottom of the container. So that's the difference in terms of separation. You can also look at filtration. So filtration is like you have a container here and you have a filter funnel. You can put a paper here and then you pour your solution in here. So if you filter a solution, it just passes through the filter paper into the container. You do the same thing with a colloid. It also passes through the filter paper. So these two are going to pass through the filter paper. Now, if you do the same thing with suspension, the suspension will be a residue. It will not pass through the filter paper. So you are going to see a solid on your filter paper. Another thing that distinguishes especially a solution from a colloid is a beam of light. So if you take a flashlight and pass it through a solution, the light will pass through it and you will not see the beam of light. You won't see it at all. It will just pass through it. Now, if you pass a beam of light through a colloid, you are going to see it. You are going to see the beam because a colloid is going to scatter light. Solution does not scatter light. A suspension usually will just block the light. So in terms of the examples, a solution, one example is salt solution. A colloid, we have mayonnaise. A suspension, we have muddy water. So let's look at what I was talking about. One way to distinguish between a colloid and a solution is what we call a Tyndall effect. So Tyndall effect really deals with the ability to scatter light. So as you can see here, if you pass a beam of light through solution, there is no color, there is no beam here, there is no beam passing through this. It doesn't mean the beam is not passing through. The beam is passing through, but it is not scattered, so we can't see the beam. But now look, for the colloid, you can easily see the beam here because light has been scattered. Now the same thing here, this one usually blocks, but if you have tiny suspension, they will also scatter light. So one way to distinguish between a colloid, one way to distinguish a colloid from a solution is the Tyndall effect. So you just see if it scatters light. If it scatters light, then it's a colloid. If it does not scatter light, then it's a solution. It's easy to distinguish between a suspension and a solution because a suspension you can see things suspended there, so you don't have to worry. But sometimes a colloid looks like a solution. So for you to know for sure that this is a colloid, not a solution, you need to use the Tyndall effect experiment, where you pass a beam through the mixture and see if light is scattered, then it's a colloid. If the light is not scattered, then it's a solution. So that is very important. You can see here, light beam in solution is not visible. Here it is visible. Here it is also visible. Now these are just examples again. You can see solution here. At first, in A here, we have sugar and water. And when the sugar dissolves in B, the sugar disappears. You can no longer see the sugar. You just see the liquid there. The sugar is still there, but it has dissolved. While a colloid, you can see that everything is uniform. Everything is uniform, but it doesn't look like a solution. In a suspension here, you can see these black spots. You can see the red spots. You can see different spots here. So that tells you that it is a suspension or a heterogeneous. So as we said, this one is homogeneous. This one is also homogeneous, but this one is heterogeneous mixture. Now let's focus on a solution. So I am just reiterating what the definition of a solution is. So we are saying a solution is actually a homogeneous mixture. So this homogeneous mixture contains a solute. Usually this solute will be less than 1 nanometer particle size. So it contains a solute and a solvent. So a solute dissolves in a solvent. So these are particles that dissolve in a solvent. So a solute is a minor component of a solution. Minor component of a solution. So what it means is a solute is has a lesser amount than the solvent. Now, solvent is usually the major component where the solute is going to dissolve. So the major component where the solute dissolves. So in terms of a solution, the solvent is usually in larger amount than the solvent, than the solute. So solvent is in larger amount than solute. So for you to make a solution, you need to have a solvent and a solute. So sometimes you can have two solutes. You can dissolve sugar and salt in water. So you're having more than one solute. But what we are saying is solution is composed of solvent and solute. And we also need to take note about the size of the particles. Less than 1 nanometers. So that is a solution. Now, in terms of solutions, we have several types of solutions. So we look at them and say, what is the solvent? What is the solute? So what is the solvent? What is the solute? So the first type of solution is liquid solvent, liquid solute. So an example for this is alcohol in water. So you can dissolve alcohol in water. Water being your solvent, alcohol being your solute. Then we have liquid solvent, solid solute. So this one is salt in water. So salt is the solute and water is the solvent. Then we have gas solvent, gas solute. In this case, we look at oxygen in nitrogen. So oxygen in nitrogen mixture is called air. So air is gas solution. Then we have liquid solvent and gas solute. An example are carbonated drinks. So in this case, we have carbon dioxide in water. So these are examples of solutions. These are different types of solutions. So take note of these different types of solutions. So this table is just repeating what I already said. So I'm not spending time on it. Now, we want to look at the basic level. What happens? What makes it possible for like water to dissolve things? So that's the question that we want to answer. Why is water able to dissolve substances? Why is it a good solvent? So before we do that, we look at what we call hydrogen bonding. So hydrogen bonding is usually like a physical bond, not really a chemical bond, but it's kind of a physical bond. There is an attraction between molecules. So hydrogen bonding really results from attraction between molecules. So hydrogen bonding is very important. So by definition, we are saying hydrogen bonding results from the attractive force between a hydrogen atom covalently bonded to a very electronegative atom. So what we are saying is I have a very electronegative atom like nitrogen here, and then I have hydrogen covalently bonded to that very electronegative atom. So nitrogen is one of the electronegative atoms. And here we say, and another very electronegative atom. So I'll put another electronegative atom here, like oxygen. So like oxygen in water. So if we go back to the definition, attractive force between a hydrogen, which is this hydrogen, covalently bonded. This is a covalent bond to a very electronegative atom. This is a very electronegative atom. So such as N, O, or F atom. And another very electronegative atom. So this is another very electronegative atom. So hydrogen bond will form between these two. So it's not a complete chemical bond. It's kind of like a physical bond of some kind, because the two molecules are not actually touching, they are just attracting each other. So if we look at water, the structure of water So if we look at water molecules, the water molecules will look like this. So if you talk about hydrogen bonding, there is this hydrogen covalently bonded to oxygen. This hydrogen also covalently bonded to oxygen. So water will form these hydrogen bonds among itself. So the question is, why is water able to form these hydrogen bonds? The answer is, if you look at water, this is the structure of water. Oxygen is more electronegative than hydrogen. So there will be a polar bond in water, such that the oxygen here will be partially negative, the hydrogen here will be partially positive. That's what we are having here. This is partially positive, this is partially negative. Now this hydrogen here is partially positive, the oxygen here is partially negative. The hydrogen here is partially positive, the oxygen here is partially negative. So what happens is these partial negatives and partial positives attract each other. So partial negatives and partial positives attract each other. Now, once they do that, that attraction is called hydrogen that attraction is called hydrogen bonding. So that's one thing special about water. Water has this hydrogen bonding. One, it is polar. Two, it has hydrogen bonding. So in conclusion, we can say that water is a polar molecule. That is one advantage. The second advantage is that water has hydrogen bonding. So what is the advantage of this? The advantage is that water is going to dissolve other polar molecules. So water is going to dissolve other polar molecules. We call this likes dissolves likes, or birds of the same feather. So that's what is going to happen. Now let's look at some questions. Before we go there, let's look at water and ions. For example, we want to try to dissolve before I talk about the dissolution, I will also just talk about water and ions. So the structure of water is this. We know this is partial positive, this is partial negative. Now, if you put an ion close to water, a sodium ion is a positive. So a positive is going to get attracted to the oxygen. Now, if you take chlorine is a negative. This is partial positive, this is partial negative. The chlorine is also going to be attracted to the hydrogen. So there is interaction between water and ions. So between water and ions. So this interaction is called ion dipole. So dipole means water is polar. That's what it means. So there are two things about water. Water can form hydrogen bonding. Now that is when it is not dealing with ions. Water can form ion dipole. That is when it is dealing with ions. So we need to take note of that. So water forms hydrogen bonding with non-ionic solutes. That is one. Water forms ionic dipole interactions with ionic compounds. So need to remember, this is not hydrogen. This is not hydrogen bonding. It is just ionic dipole interaction. That's how water is able to dissolve ionic compounds, because it can form ionic dipole interactions. Now the question is, what substances are going to dissolve in water? First, they must be polar compounds. They must be polar compounds because water is also polar. Or they must be ionic compounds. Because water can undergo ionic dipole interactions. So you look at a molecule and say, is this molecule polar? That molecule is likely to dissolve in water. You look at another compound and say, is this ionic? That compound is likely going to dissolve in water because water produces favorable conditions for dissolution. So the question is, how does this process of dissolution work? Now, for example, let's say I have my solute, which is sodium chloride. So I start with my sodium chloride solid. If I dissolve this in water, the sodium chloride is going to dissociate or disintegrate to form ions. So this forms ions. So the ions will be sodium plus and chloride minus. Now, because these are dissolved ions, we call them aqueous. So they are in aqueous form. Now, what does aqueous form mean? What happens when you dissolve sodium chloride? The water molecule will try to break apart the sodium chloride. So water molecules, so when NaCl is dissolved, water molecules breaks it apart into individual ions. Then the water molecules surround the ions. That's what happens. So they surround the ions in a process that we call hydration. What does this hydration process involve? Now let me get rid of this part. Just show you what is actually involved. Now, when you dissolve sodium chloride, because of the dipole interaction, sodium will stay here, and then the oxygens of water will come close to sodium and surround it, make a blanket around it. And then the hydrogens will make a blanket around the chlorine. So let me move the hydrogen a little further. So that's what happens. So the sodium is surrounded by water, the chlorine is surrounded by water also. Now this blanketing prevents the ions from coming back together. So the ions are surrounded by water, which prevents them from bonding again. So the process by which water surrounds the ions is known as a hydration process. So really, in hydration, the water surrounds individual ions. This is what the solution is about. Now, that was dissolution of salt. So dissolution of salt, we said, is possible because of ionic dipole interactions. But another question is, why does ethanol dissolve in water? So we have ethanol structure here. Now, ethanol dissolves in water because it is able to make hydrogen bonding in water. So ethanol dissolves in water because it can make hydrogen bonds with water. So how does it work? Let's say this is the ethanol molecule and this is the water molecule. We know that this is partially negative, this is partially positive. This is partially negative, this is partially positive. So ethanol can make hydrogen bonding and water can also make hydrogen bonding. So that is, ethanol is like water. As such, it is able to dissolve in water because of the presence of hydrogen bonding. Another question is, why does sugar dissolve in water? Actually, sugar has high solubility in water. I would say high dissolution. Sugar has high dissolution in water. Why is sugar able to dissolve in water? That's the same reason. The molecules of sugar make hydrogen bonding with water. So the molecules of sugar make hydrogen bonds with water. And you see the molecules of sugar will make strong hydrogen bonds with water. The reason is here. This is a hydrogen bond that can be made with water. This is another hydrogen bond there, because each of these are like ethanol or like water. Another hydrogen bond here. Another hydrogen bond here. So you can see that we have so many hydrogen bonds in sugar. Another OH here. That's another hydrogen bond. Another hydrogen bond here with water. Another hydrogen bond here with water. So sugar has so many hydrogen bonds that it can form with water. That's why sugar is able to dissolve in water. So you look at these hydrogen bonding centers. So sugar has several hydrogen bonding centers. So it is able to easily dissolve in water. It is able to easily dissolve in water. So that's why sugar is able to dissolve in water. Why does gasoline not dissolve in water? So like the biggest part of gasoline is octane. Let's say octane. So this molecule here does not have, so octane is not polar. That is one. Octane does not have hydrogen bonding. So being nonpolar means it cannot dissolve in water. It cannot dissolve in water. So gasoline can dissolve in other nonpolar solvents. Can dissolve in other non-polar solvents. So it will not dissolve in a polar solvent like water. So that is an important thing. Now, lastly, we'll talk about saturated and unsaturated solution. So a saturated solution this solution will contain no more solute. So will dissolve no more solute. So you see that the solute will start appearing like crystals, solid crystals in the solvent, which means the solution can no longer dissolve these solutes. So at that point, the solution is saturated. Unsaturated solution, this solution is still dissolving. Is still dissolving solute. So you keep on adding and the solute dissolves. You add more, the solute dissolves. You add more, the solute dissolves. It means that that solution is not saturated. But then when you keep on adding, the solution will come to a time when it will become saturated, such that you will no longer dissolve more solute in that solution. So these are important definitions and important background to solution chemistry. Thank you.